Accounting Rio Hondo, 102, Tuesday, Thursday evening. This is Chapter 25, Problem 25-4A, which we're going to do right now. Net present value method, internal rate of return, and analysis. At the end, we'll want to select one of the projects. Okay. Select whether the radio station or the TV station. All right, they each have 4 years, and this is for Quest Media. These are 2 capital investment projects. Here are the estimated cash flows. They are the same for each year, whether it's the radio station or TV station. For each project, the cash flows are the same, which is going to make it easier for the calculations. Use the present value of an annuity of $1 at compound interest table, also in question 4. And I have the tables right here, so I'm going to be referring to them. You have your tables in your homework. All right. I'm going to make this less than 10 minutes. Okay. To get the present value for each project, we first need to calculate the present value of the cash flows. So the TV station and the radio station cash flows for the TV station is $760,000 times the present value factor. So this is the present value of the net cash flows. Okay. Net cash flow being differential revenue less differential expenses is the net amount. All right, so we need to, each are 4 years. Okay, that's 4 years. And what is the rate? These are an annuity. They're same amount each year, annual amounts. So we have 4 years, and we need to know the interest rate. So let's keep reading on. Usually it comes with the last requirement. Okay, use a rate of 10% is what it says under the last instruction. And 4 years, 10% is 3.17. There you go, 3.17. So we're going to multiply the 760 times 3.17, and that equals $2,409,200. Okay, we're going to do the same thing for the radio station. It's 380,000 times the same factor, 3.17, and the total is 204,600. Okay, put a dollar sign by the first one, and that's the present value of cash flows, and we need to subtract out the investment. And so we just transfer the numbers down here. Radio station 1,204,600, and for the TV station 2,409,200. So these are different sized projects. Amount to be invested $1,154,060 for the radio station, and $2,169,800 for the TV station. We subtract those, and you can enter them in Cengage as a negative number, and the net present value is $50,540 for the radio station and $239,400 for the TV station. Based on net present value alone, you would rank the TV station first and the radio station second, and they both meet the 10% return. Actually, you can't tell right now which one, what the actual internal rate of return is, but I think we will. in a little while. So keep that piece of paper, or yeah, okay, you have your worksheet homework all in one sheet. Okay. Compute a present value index for each project, round to 2 decimal places. Okay, and for the radio station, it is 1,204,600 divided by 1,154,060. So this is the present value of the cash flows, and this is the investment or initial cost. Same thing. So 1.04 is to 2 decimal places. Okay, now the present value of the cash flow for the TV station is 2,409,200 divided by the investment, 2,169,800. Okay, and that is 1.11. Okay, now let's determine the internal rate of return for each project by computing a present value factor for an annuity of 1 and using the present value of an annuity of 1 in the table. Okay, now it's a really present value factor of an annuity of 1 in the table. Okay. Or you could just say the present value of annuity of 1 table. I think that might be even better. Okay. Now, I want to show you a formula proof for this to show how we get internal rate of return. Okay. Internal rate of return is where net present value is the present value factor of an annuity where net present value equals 0. So that's net present value equals 0. So NPV equals 0 equals the present value factor of an annuity times your annual cash flows minus the investment. Okay. All right. Then if you bring the investment over to the left side of the equation, we can replace these equals 0. You just say investment equals present value factor, and we'll put that little a there so you know you're using the annuity table, times annual cash flows. We need to say annual because meaning that they're the same each year. Okay, now we have investment equals to the present value factor from the annuity table times annual cash flows. If we take annual cash flows and put it to the other side of the equation, we will divide investment by annual cash flows. Okay, divided by that equals our present value factor for annuity, and then we look it up in the table to see what the rate of return is. Okay, so let's go ahead and do it for the radio station. I did this in green because this is the formula proof, and so I hope you can see it in green on my screen. Right now it looks black, so maybe you can't tell the difference. Okay, so for the radio station, okay, the radio station is annual cash flows I'm sorry, investment divided by annual cash flows, 1,154,060 divided by the cash flows of 380,000 per year. And that gets a factor of, you said round to 3 decimal places for the present value factor. So we have 3.037. For the TV station, we have 2,169,800 divided by 760,000 equals 2.855. Okay, now we pull out our table and we're looking for, let's look for 3037 first on the 4-year line. So we're looking up the 4-year line. 3037 is 12%. 3037, 12%. Okay. So the present value factor of an annuity, 3037, and the rate is 12%. Okay, the TV station, the rate is 2855. Okay, that's our 10 minutes. We're only going to be a few more seconds longer. The formula took longer than I thought. Okay, but hang in there. So here we have 2855. On the 4-year line, 2855 is 15%. Okay, so how are we going to rank these based on the present value index? How would we rank them? Okay, the ranking would be, originally we said TV station is 1, radio station is 2. So here the TV station is 1, the radio station is 2, and based on internal rate of return, the TV station is 1, the radio station is 2. So for all 3 things, we have the same ranking. We can be very comfortable if we can only afford one of the projects to go with the TV station. And that's it for this problem.